One of the important use of galvanic cells is they are used as a portable source of electrical energy. As a portable source of electrical energy. These cells are used as a portable source of electrical energy. These cells are commonly known as batteries. These cells are known as batteries. These cells are known as batteries. So batteries, what is battery? A battery is an arrangement of two or more cells of two or more cells connected in series. These are known as batteries. A battery is arrangement of two or more cells connected in series. Thus, batteries are arrangement of electrochemical cells, or we can say these are arrangement of electrochemical cells used for source of electrical energy. Arrangement of electrochemical cells used as a source of electrical energy is the battery. So, now what are requirements of a battery? What are requirements of these cells? कैसी होनी चाहिए? What are the requirements? What are its requirements? A battery, a cell, these should be, that is, a battery should be, or a cell, it should be compact. Number first, it should be compact. This is the requirement. What is the requirement of a battery? Compact and easily transportable. Easily transportable. Number second, should have long life. Number third, voltage drop should not be sudden. Drop should not be sudden. In case of cell, the voltage drop should not be sudden. These are the requirements of the battery. Number first, it should be compact and easily transportable. Number second, it should have long life. Voltage drop should not be sudden. Now, these cells are of two types. Number first, primary. Number second, secondary. So, what are primary cells? These cells are in which electrode reaction which takes place. Actually, the basis of these all these reactions cells is oxidation reaction. I will write here basis of these cells. Base of these cells is oxidation reaction. Is oxidation and reduction reaction. That's redox reaction. Now, primary cells are those cells in which electrode reaction, that is this reaction which takes place at electrodes, electrode reaction is not reversed. That is not reversed. by external source of energy, external electrical energy source. That means these cells, in these cells, the electrical reaction is not reversed by external electrical energy. That is, they are not recharged. They are not recharged. These primary cells are not recharged. They become dead after use, after single use. जो ही आप इस्तेमाल कर सकते हैं इनको, तो electrical reaction is not used, external energy is not used, or the electrical reaction cannot be reversed. They are not recharged. These cells become dead after use. These are the primary cells. Now secondary cells, in these cells, electrode reaction is reversed. Electrode reaction is reversed by external energy source, by use of external electrical energy. That means they are recharged. These cells are recharged. That means they can used again and again. अब ड्राई सेल जो है, इस प्राइमरी सेल्स की मिसाल जो है, उसमें आप देखते हैं ड्राई सेल है, इसमें जो है रेड स्टोरेज सेल की मिसाल है, रेड स्टोरेज सेल. So primary cells are those cells in which electrode reaction is not reversed by external energy source. They are not recharged. They become dead. For example, dry cell है, और जो secondary cell है, इनमें electrode reaction is reversed by use of external electrical energy. That means they are recharged and they are used again and again. जैसे lead storage cell. These are called storage cells also. Secondary cells are called storage cells. Now we will study one of the primary cells, that is dry cell. What is dry cell? Students, this cell was invented by ᴄᴇʟʟ in 1868, and this word dry it is misleading, because moisture is indispensable. Moisture is indispensable. So without moisture the reaction cannot take place. So this word dry is misleading because the moisture is indispensable. Now this was invented by ᴄᴇʟʟ in 1868. I will show the construction of the cell. The cell consists of this zinc cylinder. Now first, it consists of zinc cylinder. This is the zinc cylinder. This zinc cylinder acts as anode. This zinc cylinder is lined by a porous paper. This is lined by a porous paper. And this zinc cylinder is filled with a paste of ammonium chloride and zinc chloride. This paste is the ammonium chloride. This is the paste of ammonium chloride and zinc chloride. This is the paste of the zinc cylinder is filled with the paste of ammonium chloride and zinc chloride. In the center, there is a carbon rod or graphite rod which acts as cathode. So, cathode is carbon rod or graphite rod. This rod does not touch the bottom. It does not touch the bottom of the cell. Now, this rod, cathode is surrounded by black powder of manganese dioxide and carbon. The mixture of manganese dioxide and carbon. Cathode is surrounded by manganese dioxide and carbon. During the reaction, zinc rod gets consumed. When the cell is in use, this zinc cylinder, it gets consumed and develops the holes which cause the leakage of the cell. Now, the reaction which takes place in the cell is as zinc rod lose electrons at anode. Zinc rod lose electrons. Zinc this cylinder lose electrons gives zinc dipositive ions plus 2 electrons. This is the oxidation takes place. Now these electrons which are generated in the zinc cylinder, they pass to the external circuit and zinc dipositive ions pass in the electrolyte. Zinc ions pass in the electrolyte. This is reaction at anode. At cathode, these electrons are accepted by ammonium chloride. Ammonium ions are there. They accept the electron, give ammonia gas plus hydrogen. So the reaction, overall reaction at cathode and anode is Zn dipositive plus twice NH4 positive gives Zn dipositive plus twice NH3 ammonia gas plus hydrogen gas. Now this hydrogen gas does not come out. Neither the ammonia comes out nor the hydrogen comes. This hydrogen gas so formed, it is oxidized because it causes a reaction of manganese dioxide. In case of there is manganese dioxide, it combines with the hydrogen gas and gives manganese dioxide, this compound, and oxidation state of manganese changes from +4 to +3. Oxidation state of the in case of manganese dioxide changes from +4 to +3. Now ammonia formed here, it does not come out, it combines with the zinc ions and chloride ions which are ammonium chloride gives complex which comes out when the cell leakages. So it also reduces the pressure of the gas and it does not cause the rupture because ammonia so formed may increase the pressure, but it combines with the zinc dipositive ions and forms the complex compound. Now this reaction, this cell gives a voltage of 1.2 to 1.5 volts. I will repeat it again. The cell consists of a zinc cylinder. Zinc cylinder acts as anode. This is filled with the paste of ammonium chloride and zinc chloride. In the center there is a carbon rod or graphite rod which acts as cathode. It is surrounded by the manganese dioxide and carbon powder. During the reaction, zinc gets consumed because oxidation takes place here, and it can in the long run develop the holes. The reaction which takes place, zinc loses electrons, gives zinc positive ions, oxidation takes place at cathode. These electrons are accepted by ammonium ions and give the ammonia gas, this hydrogen gas. But this reaction, this ammonia gas and ammonia gas does not come out. Hydrogen gas so formed combines with manganese dioxide, gives twice MnOH. Oxidation state of manganese change from +4 to +3. Zinc dipositive ions combined with the ammonia gas and chloride ions give the complex. In this way, the reaction proceeds. You must know, since this ammonium chloride is acidic, if we keep the cell for a long time without use, it causes corrosion and it is not then able to use because it causes corrosion of the zinc, so it is not used. Because for long, if the cell is taken and is not used, even though the cell gets unable to use because ammonium chloride causes the corrosion because it is acidic in nature. Thank you. This was the dry cell.